This conference will now be recorded.
Hello, everyone. Thank you, everyone, for joining. So, my name is Igor Gashawara. I'm maybe still the co-chair of the Early Career Society on AquaWatch. Uh, and I'll be rotating out of the co-chair position, and well, we will have new co-chairs in this year. And today we will have our third talk on the Water Talks. So the Water Talks is a platform to give the voice, especially to early careers researchers. And today it's my great pleasure to introduce you to Ileana Callejas, sorry, Ileana Callejas. She's an assistant professor at biological science at Biola University in Southern California. She got her PhD in environmental engineering from UCLA and a master's degree in water resource engineering and bachelor of science in environmental science with a minor in environmental engineering. And today she's going to present a little bit of her previous work on the Belize project. And Ileana, the floor is yours.
All right, thank you. So thanks everyone for coming. Good morning, good afternoon, good evening, whatever part of the world you're in. In this talk, I'm just going to be sharing about a toolkit that I made during my PhD that's for water quality, for monitoring it for SDG 14, which I'll explain more, for coral health in marine protected areas in Belize. And then just to give a little bit of background about myself, right now I am an assistant professor in uh, biosciences at Biola University, which is a small Christian university in California. And then I am a triple Bruin, which a lot of my studies being in environmental science and environmental engineering. And my PhD experience was very interesting because it was during COVID. And so I actually thought I would end up doing more wet lab kind of work, which I did do, but I ended up doing a lot of satellite remote sensing during the pandemic. And so just to give a little overview of my research, so I do have, and I did eventually come back to doing more research in antibiotic resistance. So if you've heard of the term superbugs, things like that in the environment. And then during COVID, focusing a little bit more on satellite remote sensing. And then with that satellite remote sensing, I thought those are really great tools that I think can really break down the barriers of research and um, just being very accessible, especially with like open source platforms like Google Earth Engine. And so I did do um, some research in environmental education. And so I'm actually going to share a little bit about that first. And so before I share about the toolkit, and so with my advisor, we were able to make some Google Earth Engine modules and then put it into a STEM and a non-STEM course. And so we were able to see some increases in some of the confidence of the students in coding and understanding remote sensing. And then we had the STEM students take it a bit further and actually make some maps, make some plots. And so here's just an example of one of the student groups that saw differences in during COVID in the turbidity in Bangkok, Thailand. And so those are things that I'm always trying to do. And I'm actually teaching a land resources course where I'm integrating remote sensing and QGIS. And so if anyone ever has any ideas, I'd love to hear. But so moving on to our talk for today. So just to give some background on Belize, if you don't know where Belize is, it's a small country in Central America, and they have a lot of biodiversity and forests, mangroves, and coral reefs. And it's actually, I think, one of the second largest reef systems in the world, and it provides a lot of monetary value in tourism, um, in the food, but then also in some indirect costs, like maybe coastal protection from hurricanes and tropical storms. And actually, over 60% of the population actually depends on the goods provided by the coastal and marine ecosystems in some way. And so the country is very concerned with how to maintain their coastal resources. And so one group that I worked with a lot for this project is the Coastal Management Authority um, Authority and Institute. And so they're kind of the government arm that's leading the way on managing those coastal resources. And in 2016, they released their Integrated Coastal Zone Management Plan, and they just recently went through a process where they're doing an update or an interim, and that's supposed to be paving the way um, for them to have something that's legally enforceable in the future. And they actually have this interesting thing where they're kind of trading their debt for marine conservation with an agreement with I forgot the organization, but with a conservation organization. And so they really have to see how they're going to expand their marine protected areas and trying to use the best science so that they can have grounds to make something legally enforceable. And then this is just an introduction to the United Sustainable Development Goal 14, which was really the motivation for this work. And so under this goal is to conserve and sustainably use ocean, seas, and marine resources. And I'll get into the specific one that was the main focus of this project. And so here is just a map of where our focus was, which is the marine protected areas in Belize. And so you can see they're just all across the coast here. And there's around 20-ish of them. And then these were our research questions. So we wanted to see how sea surface temperature and water clarity has changed within these marine protected areas. I'll refer to them as MPAs from 2002 to 2022. And then if this workflow can be used to see which marine protected areas need more help, maybe more focusing in on for the upcoming coastal management plan. And so for this work, I used aquamodus imagery. And so this mission has been going on since 2002, and I think it's actually going to be decommissioned if it's not already decommissioned. And so for this data, I ended up using KD490, which is a proxy for turbidity, water clarity, and then sea surface temperature. And so why do we want to study water clarity? What does that have to do with coral reefs? And so just some of the background here is that if there's increased sediments, then that will reduce the water clarity in the water column, and that will restrict the light from getting to those organisms at the bottom of the water column that need it to grow and to sustain itself. And then there can also be increased nutrients, especially in some parts of Belize, particularly in the north, where maybe there's more algae and that can grow on the corals and can lead to coral disease and things like that. And then for this project, particularly we're working on target 14.1 of that SDG 14. And so that's to reduce marine pollution of all kinds, particularly from land-based activities. So just to give some background on what KD490 is, that is the diffuse attenuation coefficient. And so it's just how the light intensity is being reduced with depth. And so here in general, we're wanting, if we see, for example, a high KD490, that is a small attenuation depth, and that's a low water clarity. And then if we have a low KD490, which is more so what we want for the coral reefs, that means that there's a large attenuation depth and a high water clarity. And then the other term that I'll be talking about a lot is this concept called the degree heating week. And so the acronym will be a DHW. And so that's a common measure to understand the long-term thermal stress on corals, and the units, interesting, they're degrees Celsius weeks. And so basically how that's calculated is that you're seeing what is the thermal stress over this 12-week period. and then you're comparing that temperature to the maximum monthly mean for that area, and then depending on how it's accumulating over those 12 weeks and dividing it over the 7 days, then you can get a certain value for the DHW, and then there's categories for that. And so if there's a DHW of 0, that means there's no thermal stress. DHW over 4, that could be signs for significant bleaching. And if it's over 8, that can be stressed. The corals can be stressed for bleaching and even mortality. And so this is the specific threshold that I used for Belize that I got from the literature from a project that was looking specifically at what is that threshold for Belize. And so I was able to make this toolkit and this workflow that I have on GitHub. And so basically the data for the KD490 and sea surface temperature was gathered from Google Earth Engine. And then for the sea surface temperature, we did that calculation for the degree heating weeks, and that classification is actually based on NOAA's Coral Reef Watch. And then there was that specific threshold of 29.7 degrees Celsius for Belize for those temperatures. And then we also looked at the September sea surface temperatures, because that is actually the hottest month. That's the highest, that usually when the water temperature peaks in Belize. And so we wanted to see how those were progressing over time. And then for the KD490, we also did some thresholding classifications based on some literature that looked at what are the threshold values, global and specific to the Caribbean, for what KD490 should be for coral reefs to be able to thrive. And then for both of these data, I did a yearly average for both per MPA per year, and then assigned a median z-score based on all of those years. And then from there, assigning a ordinal value based on that z-score, and then I combined them in an equal weight in order to get a coral vulnerability index, so that we could rank the marine protected areas to see which are the ones that are most stressed for the sea surface temperature and this turbidity. And so here are just some of the results of some of those general patterns. And so for about half of, maybe a little bit more than half of these, there was a lot of these little to no stress. So here you can see some of the categories here for the turbidity, the KD490, based on some of those thresholds. And then here we can see the 2002 to 2022, and then the KD490 over here. So around half of these, a little bit more than half, were mostly in this little to no stress categories. And then some we saw had some issues, like for example, this Corzal Bay, which is that some of those areas within the north part of the country has a lot of issues with algal blooms and fish kills in those parts of those watersheds, where throughout most of the time they're actually very turbid. And then there's a few areas kind of like this where you see more of the seasonality with the turbidity. So this is a port that's kind of in the southern side of the country. And then here are some of the patterns for the sea surface temperature and the degree heating weeks. And so here's the degree heating weeks, those NOAA categories. And so those are here at the bottom. And then the sea surface temperature, we can see those seasonalities here at the tops of the plots. And so I would say probably around also a little bit more than half of them were kind of in having this little to no stress of the degree heating weeks, such as this blue hole, which is a very popular tourist area in Belize, very well known for diving and snorkeling. And then this one maybe in the more recent years having a little bit more trouble with the bleaching risk, the temperature stress. And so this is another conservation area, Holchan. And then there are some areas that were closer to the coast that had more of this mortality risk and bleaching risk, such as this port area. That's again in the southern part of the country. And then here's just some of those results from looking specifically at the September sea surface temperatures. And we did do some statistical analysis, and we did see that indeed that the September sea surface temperatures and all has been increasing in the marine protected areas. We also know, that globally this is occurring, with particular in this 2008 and maybe in these last 5-ish years, that the sea surface temperature has been increasing, which we know is not good for the coral reefs because it can cause the coral bleaching and things like that. And then so this is the results from the Coral Vulnerability Index. And so here are the marine protected areas, the median z-scores for KD 490 and sea surface temperature. And then depending on the range, they were assigned a value. And then with those respective values, they were combined to get a coral vulnerability index. And so we can see that maybe some areas they're a bit more stressed out in terms of the sea surface temperature, others maybe more with the turbidity. And so this is just a tool to kind of help to see what are the marine protected areas that may need more interventions in the future, in those future management plans. And so we did eventually get to go to Belize once the international restrictions were lifted, and then they actually were, not surprised with some of these areas, such as this port area that I guess has also had some issues. And so this was just a way to rank them to see what are the areas. And so this study is out, and then the NASA Jet Propulsion Lab did do a little feature on it. And so I just wanted to share again the cultural relevance of this type of work and using this satellite remote sensing to really help to manage these coastal resources or any water resources. And so this is just an excerpt from one of those Coastal Zone Management Authority and Institute folks, and just them just saying that a lot of their cultural identity arises from the marine areas, and it's a measure of pride. Wherever Belizeans go, people know the coral reefs. And then so this is just a picture of that really nice blue hole. And so in all, these were just the main findings, that the Corozal Bay, Swallow Cay, Port Honduras, some of these places had higher percentages of these stress days, higher coral vulnerability index scores, and that there was statistically significant increases in the September sea surface temperatures. And I will be continuing some of this work later on. I'm actually going to take some time of leave to do some more of this work at NASA Jet Propulsion Lab through the NASA postdoc program. And so a lot of this work was actually done through that interesting time where there wasn't really international travel, but I did eventually get to go to Belize and meet some of these people that I was working with. Not so much to do this continuing this work, but more so with that antibiotic resistance work. And so actually taking water samples and filtering them, bringing them back to the US and seeing what kind of bacteria and antibiotic resistance is in their waters. And so I actually had a little fun video that I wanted to show of just of that trip, so you can actually see what this place looks like. it's just a fun video that I love to show students, to show what research could look like in different places. So, you work hard, you play hard too. And so, with that, I thank you so much for your attention. And I just wanted to leave my information here in case anyone wants to connect or chat further, or even has any ideas for stuff that how this potentially could be continued as well. Yeah, thank you.
Thank you so much, Ileana. We already have a hand. Someone, Carolina Peralta. Do you wanna start with our first question?
Hi, hello. Ileana, congratulations for your presentation. I really enjoy your talk. And one of the things I could appreciate is how you enjoy and you like what you're doing. This is really an inspiration for others. So my question is more like a curiosity about one of the slides you show, the one where you highlight the September sea surface temperature peak. I don't know, in my screen I couldn't see very well the details, but I could see some like repetitive event of of increasing the temperature, and I was wondering if you could observe or see some like kind of cycle that repeats again every, I don't know, 3-4 years. You have again that peak. Yeah, I'm just curious about that.
I don't know if I looked too much at the patterns, but I think they may have gone with like the El Nino and things like that.
Mm,
I think I do remember looking at that and seeing like, oh, if there was an El Nino year, or if there was particularly a lot of like big hurricanes, tropical storms, those particular
mhm.
years, that is the certain time is usually in the fall time where they will have those events. And then I do remember 2020 was particularly a bad year for them and Central America as a whole.
Yeah, I kind of saw something like that, and I was just wondering if you saw that relationship with maybe El Nino, La Nina, or some other like natural event happening around the region. So yeah, it's just that from my side. And again, congratulations. I really like your talk, and looking forward to see some other progress or results, or to get in contact with you for future, I don't know, other opportunities. Thank you.
Yeah, thank you.
There are some questions in the chat from Mary Beth. I don't know, Mary Beth, you want to ask them directly?
Sure. I'll be happy to do that. Ileana, I just wondered, you mentioned that there's an opportunity uh, to intervene maybe on marine protected areas that have a high coral vulnerability index score. I wondered which would it be, an agency or an NGO? Who would do the intervening, and maybe what, if you could elaborate maybe on what actions they might take that would be useful. I suggested maybe efforts to reduce turbidity, or advise that maybe the snorkel areas are closed if there's too much pressure from having people swim in those marine protected areas.
Yeah, I think it would be that Coastal Zone Management Authority and institute, that governmental group. And I think so they're the ones that are trying to lead that effort to see how can they use science and what they know to make something legally enforceable. So maybe making some areas to be no fishing. Maybe I don't know if they'd reduce the tourism, just because I think that is tricky because it is such a big source of income for the people there. I know they've had some issues. For example, I didn't talk about this, but with agriculture, and so the erosion of soil and sedimentation and having some of that flow out to the coastal lagoon. And so they would be the ones that would have those recommendations for the country and seeing how they can help to preserve some of those areas more. And for sure they do have to, I know in their plans they do have to expand those protected areas.
Thank you so
Thank you,
much.
Ileana. I think I see a hand from Frank Miller-Carger.
Yeah, hi. Hi, Ileana. Thank you very much again. Good to meet you. I had a question. Maybe I missed it in your description of the data, the spatial resolution of the MODIS data that you used, especially for KD 490. And so that would be one. And if the resolution is, I think the best would be 1 kilometer, and I don't know if you used 4 kilometer. So that would be one question. How do you fit things like the blue hole and something like that? But more than anything, I wanted to know how you justify the use of these data in shallow waters, and how did you deal with it, or what was your assumption, or you just looked for change, it didn't matter how shallow it was?
Yeah, so I did use the 4 kilometer, that level 3 data that's available in Google Earth Engine. And it actually, yeah, it has been a little bit tricky, especially with the very reflective bottom surface. So that is something that in this team that we were talking a lot about, like how can we try to see how you can remove the effects of that very bright sand in this shallow areas. But I guess for our justification, even with this work, is that actually that a lot of people have used some of this AquaModis data to look at coral reef areas, and so that's what kind of the justification was for this kind of work. But I do agree that in the future, have to see what to do with that shallow bottom, the reflectance from the sand. And so that could definitely be something in the future. So if you have any ideas, I'm all ears for how to rectify that or take that into account.
No, we're trying to do something similar and wondering to what extent it would be better to just stick with, for example, Sentinel-3 or some Landsat products, because at 4 kilometer, it's hard to know exactly what you're looking at. But if you're looking for just relative change, it's a good approach, you know.
Yeah, I think for the most part, yeah, for looking at the whole coast and looking at just the marine protected areas and comparing them, I think it was a start. And so for sure to pinpoint certain areas, certainly some of these smaller Ks, probably a different remote sensing satellite imagery would have to be used. Mm-hmm.
Yeah, good, thank you.
Thank you. And the next one is Alexander Castaña.
Thank you, Igor. Thank you, Ileana, for the presentation. It was very interesting. Also to get to know you. I have 3 questions, and so I guess you can not denominate the time here, so maybe you can choose which one you think is more interesting to address. But one question would be about the feedback from the government. I kind of understood from your presentation, you said, well, that's something that they expected. And so I was wondering if you managed to have an interaction with the government, or if you receive feedback afterwards, if if this study or this kind of information is being taken into account in any management or planning. That would be one question. The other question is similar to what Frank Miller-Carger did. I was wondering about because it's been quite some time since I used MODIS data, so why not use turbidity instead of 490, but also, yeah, the resolution and maybe problems with the adjacency, depending if you are too close to land. So these are a bit more technical details, but I think somewhat you answered that and Frank's question. And then finally, the third question would be if you see any particular impact during COVID for the transparency / turbidity in the water or anything related to that?
Yeah, so the first project that I ever worked on this with was actually looking at COVID-19 and that shutdown and seeing how that would affect, especially since it is such a touristic country without all of that international travel and all of those things. How did the turbidity change? And so we did actually see that the turbidity did go down after they had their shutdown in like late March 2020. And so that has been more of what the government did use within their coastal management plan. They kind of used that data to kind of reroute the marine traffic, and so how those boats are coming in to kind of reroute them. And so for this work, I'm not too sure. I'd have to check in with them, which I am going to check in with them this year to see um, if this is helpful at all, and how then can we progress this this kind of project to help them for their upcoming marine spatial planning.
Thank
Frank,
you,
you
Elena,
are
for the answer. Yep.
sorry, Alex. Frank, your hand is shown. Do you have another question or?
No, sorry about that.
Okay, so Ileana, I also have one question for you. So you mentioned in the beginning that, well, was not your plan to use satellite data for your PhD work in the beginning. Uh, and one thing that we heard a lot in the early career society is that it's really difficult to find materials or to learn more about remote sensing. I would like to know what was your experience on this?
Yeah, it was definitely tricky at first, especially for during those COVID times, because the if you think about COVID, a lot of the funding went down, a lot of the projects were cut off, and so I actually got this opportunity from one of my advisor's old students, and so it was very daunting at first because I hadn't really coded in a while. I didn't really know about satellite remote sensing. I didn't really know that even those kinds of things even really existed, but needed something to progress the PhD. And so I was like, well, we need to take on the challenge. And so um, it was a lot of independent work to try to learn all of this, especially with. So I really am thankful for YouTube and for a lot of tutorials, the Google Earth Engine community, um, for all of the stuff that they put out that was very instrumental for me for trying to learn how to use Google Earth Engine. The NASA RSET tutorials are also very good for getting fundamentals and what is remote sensing, how do the different bands work, atmospheric correction, all this stuff that goes into working with those data. And yeah, it was an interesting experience, but I'm very grateful for it. Even though COVID-19, we can see it as a time of a lot of loss, it was also a time where we can expand ourselves, expand our skills, and that was definitely the case for me. And so, and then led to other stuff too. So even doing like that education work, that was really fun to get students to also learn a bit of that. And so that's something that I'm also continuing to show students as an accessible way to partake in research, to use this kind of data.
Thank you. Does anyone have any other questions? Do you have any questions in the chat?
No other questions in the chat, at least not in the public one.
If not, so I would like to just mention some information in the chat. So if you want to join the Early Career Society, we just send an email to us and then we will put you in contact to the Early Career Society. There is a certificate, so if you need attendance certificate for today's webinar, you can send a message to Mary Beth or send an email to Mary Beth, and she will send you the certificate of attendance for today's webinar. And if someone wants to ask a very last question to our speaker today, last chance. No, so I
Igor,
would, yeah, Mary Beth.
are you going to mention the upcoming or the last water talk?
Yes, we can make, yeah.
Ileana?
Yeah, so we, as we talked before, Water Talk is a series of talks, and the next one is on February the 7th. And we hope to see everyone again in our next Water Talks talk. So thank you, Ileana, for your talk today. Thank you, everyone who attended, and good luck in your NASA postdoc. And yeah, the talk will be online later today in the AquaWatch website. Thank you so much, everyone.